Okay, so in this tutorial, we're going to add collectibles to this demo we've been building. And in the process, we'll also learn how to make an animation from a sprite sheet because we're going to actually get some real art assets instead of just our colored squares and make an animated, like a coin kind of pickup type thing. So first of all, let's go to the internet and download some assets to use for this. I'm going to use the Sunnyland Forest asset pack that's free on itch.io. Um, you can find the URL here. This is by a guy named Louis Zuno, who I actually back on Patreon. He has a lot of cool art that you can use for projects like this. So go ahead and download this, and we're going to grab this little carrot art out of it. That's what we'll use. So I'll download that now. And then once it's downloaded, we'll just go ahead and extract it. And so here it is, unzipped. And inside of this, we're going to find in the Sprite Sheets folder, there's a MISC folder. And we're going to grab this carrot.png and we're going to add it to our Unity project. So the easiest way to do that is just find your sprites folder here and bring Windows Explorer or Finder if you're on the Mac back up and just drag the PNG right into your sprites folder inside of your assets directory. Now, if you look at it right off the bat and you were to try to drag it in, there would be a number of problems. First of all, it's very small. Second of all, there's actually lots of carrots instead of just one. And it's also kind of blurry. So those are a lot of issues to deal with right off the bat. So if you select the carrot sprite in the project window, we can start fixing it by correcting some of these import settings. First of all, we will change it. We'll change the sprite mode. This is not just a single image. This is actually multiple images. So that's, if you have a sprite sheet, you want to always set it to multiple. Second, we need to fix the scale issue by telling Unity how many pixels per unit this art is supposed to be. Now, if you look at the little faint grid lines in the scene window here, that's 1 unit. This square right here is roughly 1 unit by 1 unit. So it's kind of up to the artist to decide like how big his art's going to be, like how many pixels will take up one of these units. And if you didn't make the art yourself and you don't know the artist, you have to hope that you can just, if you're lucky, you can look at the art and see if they tell you. So we can see right here it says it's 16 by 16 pixels per tile. And so that means this is meant to be 16 pixels per unit. Sometimes you can't get lucky and find that info. So you just have to open the image up, like I would open this tile set up in some image editor like Photoshop, and I would literally, use the selection tool to measure how large one tile is and see how many pixels one tile is meant to be. And then that's how we can figure out how many pixels per unit that we want to set in Unity. So in this case, we were lucky and the artist is actually telling us it's 16 here. So we will put 16 pixels per unit in. If I were to apply this right now, that would help correct the scale issue. There's actually one more setting I want to change before we do that, and that is going to be this filter mode. So hold on a second, let me get rid of the tile palette. It's kind of taking up a lot of room here, and I didn't mean to have that on. So anyway, so we're going to change the filter mode here to point or no filter. And the reason we're going to do that is because this is pixel art. And so pixel art, we want the pixels to show up without any kind of smoothing. You'll notice that if you have pixel art in your game and you don't set it to no filter, it will appear a little blurry. And that's because in most 3D games, if the player were to like walk up to a wall or something, we wouldn't want the wall texture to appear pixelated. But with pixel art, we do want it to appear pixelated. So we're not going to smooth it out. We're just going to leave it on no filter. And so we'll go ahead and apply these settings. And the next step is we have to slice the sprite. We have to tell Unity how should this sprite sheet that has actually multiple images on it, how should it chop it up into each individual sprite. So we'll open up the sprite editor, and you will see something like this. And I'm going to click the slice button because we need to slice this up into, it looks like there are 4 distinct images here. So you could use automatic, but the problem with automatic will select like the tightest boundaries right around each picture. I can just do it and you'll see. So like there's that one, there's this one, there's that, and there's that. That is okay, but since we want this to animate, it will be helpful if each frame is the same dimensions. Otherwise, it'll kind of shuffle around its position in the middle of the animation. And we don't want that to happen. So instead of automatic, I'm going to use a different option here. So if we knew what the cell size was, like each cell was the same size, we could enter that there. I don't actually know that. I don't want to measure either. What's easier for me to measure is this cell count option. So if you choose that, you'll see you have columns and rows. I can see real easily there's one row and then there's 4 columns, right? So a single row horizontally and then 1, 2, 3, 4 columns vertically. So 4 columns here, 1 row. And if I choose slice, you will see now we have chopped this image up into 4 equal-sized cells, 1 for each of the images. So that's the cell and row, or column and row rather, are a pretty easy way to chop up a sprite sheet if you aren't familiar with the cell size that the artist used. Okay, so now that this is sliced correctly, I'm going to choose apply. And now if we look at the caret in the project window, you'll notice there's this little button we can use to expand the caret entry, and it'll show you each of the separate slices that we made. So this one PNG is actually 4 separate sprites now. So we couldn't just drag all 4 of them in like that. Instead, we want to, so yeah, what's that? That's actually, that's going to try and make an animation if we do that. Instead, we just want to drag 1 caret in like that, I suppose. You can see the existing caret that we have. It has fixed itself, is now scaled better, and it's only showing the first frame of the animation. It's not showing all of them. So that's a good thing. Now, the next thing we're going to do here, since this is meant to be like a coin or a collectible, I'm going to select my caret and I'm going to add a box collider to it. Box collider 2D, that is. The box collider 2D is going to make sure we can detect when the player touches it and then have the coin go away or whatever. So remember, if we were to just leave it like that, my player can actually land on it. We don't want that. We don't want Mario to be blocked by a coin. Mario should pass smoothly through the coin while collecting it. So in order to get that behavior, we're going to have to make sure this is marked as a trigger. And now you'll see we can pass through it, but under the hood, the engine's still tracking when we touch it. So make sure your box collider is marked as a trigger. Alright, next we're going to add, so make sure you've got your caret selected, and we're going to add an animator component. It's important that you don't accidentally choose animation. That's a little bit different. We want to make sure we choose animator. So add the animator component there. And this is just going to be necessary for us to make this sprite animated. And we aren't going to get too much into the nitty-gritty for it in this example, just because the coin is only going to have an idle animation. So the animator, it has an animation controller here eventually, and you can use that to create all sorts of different animation states and transition between them. But for this simple example, it's just going to only ever play one animation, so we won't really look at the animator too much. We'll save that for another example. So once you've got your animator added, we need to open up the animation window. So choose Window from the Unity menu and find Animation. And it's kind of like a little timeline like this. I'm going to try and dock mine somewhere where I can see the scene window as well as my project window while I'm using it. So I'm going to, if you drag the little tab around, you can dock it in different spots. I want to dock it right like that. That's going to work for me. And you can see, make sure you have the caret selected still. And I'll say, to begin animating caret, create an animation clip. So one more time, I just want to reiterate. Make sure you have the caret selected, and make sure that the caret actually has an animator component on it before we click this button. Alright, so I have those steps taken care of, so I'm going to go ahead and click on this create button, and Unity is going to ask me, where do I want to make this new animation? Well, animation is a new type of asset, so I'm going to go into my root assets directory and make a new folder, and I'm going to call it animations, and we will save all of our animation related stuff in the animation folder. So make that folder and hit OK to, oh, I have to name the animation. Yeah, okay. So the coin, like I said, it's only going to have one animation, an idle animation. So we'll just go ahead and call it idle. So we're inside of our animations folder we just made, and we're going to make a new animation called idle. Now I can click save. And you can see in this animation window I opened earlier, it now says idle here. And this is kind of like a keyframe based system. So I can create new keyframes and Unity will sort of interpolate between them. For a sprite sheet, I just want to cycle between the frames fast enough that it appears like a fluid animation. So I need to add these frames here into my animation. The easiest way to do that is just select each of the frames that need to be in the animation and drag them into the animation window. And Unity will automatically set me up a keyframe for each image that I had selected when I dragged it in. Now, at this point, if I press play, you'll see the caret is animating like hyperspeed, and that is because by default Unity is going to give this a speed of 60 frames a second, and this is just not the speed the animator had in mind when he built this animation. So again, since you don't know the animator, we can't just ask him what it's meant to look like, so we kind of have to try a little guesswork. I know 60 is too fast by a lot, so I could try slowing it down to like 24 and hit enter, and you can see it automatically kind of spaced out my frames a little bit, which is effectively slowing down the animation. And that's pretty good, but well, it's better at least. It still feels like mega fast to me. I'm going to choose 12. and try that, and 12 seems pretty good. If you don't like 12, you could go slower or faster. It's your game, you pick. Or if you're lucky enough to have an artist working with you, have them set it up to whatever they envisioned it as. Okay, so um, I'll leave 12 in here for the time being at least. And the next step I need to do, well, actually, you should check it out. If you just run your game now, the caret, I believe it's going to be playing the animation by default. Now that's because there's just only one animation, and if you follow the steps the way I did, Unity will automatically hook up your animation to play as soon as the game starts. So hopefully that's what you're seeing. Alright, so now that our animation is working, we need to create a script for our collectible and make it start making its functionality. So I'm going to choose my scripts folder here in the project window, right click and create a new C# script. I will name this collectible and open it in Visual Studio. Alright, so first of all, I'm going to go ahead and delete the template because I just don't need it for now. And I'm going to move my open curly bracket to a new line because that's how I like it. And I'll delete the extra blank space because I don't need it. And I think the first thing I'll need here is an onTriggerEnter2D function. So since that's built into the Unity API, if I start typing onTriggerEnter2D, you'll see it appear in the IntelliSense dropdown. And I'll just choose enter, and Visual Studio should just fill it in automatically for me. And that's nice because I don't have to go look up. These functions that appear in blue like that are called automatically by the Unity engine. And I don't want to have to, if you spell them at all wrong or use the wrong kind of parameter, it won't work. So I want to let the computer type it in for me so that I'm guaranteed it's typed in correctly. Also, be very careful that you're choosing onTriggerEnter2D and not just onTriggerEnter. Since it's a 2D game, we have to make sure we use the 2D versions of these functions or stuff just won't work. Alright, so what do I want to have happen when the player touches my coin? I guess first of all I need to make sure that it is actually the player touching my coin. So we'll just handle that the same way we have in other scripts we've done. So this collision parameter here is a reference to whatever touched our trigger. So we'll say collision dot game object dot compare tag, and we're going to see if the thing that we touched has the player tag, and if it does, then we'll do some more stuff. What are the things we want to have happen? Well, first of all, let's just have the coin go away. So essentially, once you collect the coin should be removed from the game, right? We don't want you to be able to collect the same coin several times. So there's a way to do that by just calling destroy. And we have to tell Unity, alright, well, what do we want to destroy? We want to destroy the actual game object that this script is attached to. So we can't just call destroy this. That would destroy this script that's on the game object. We need to destroy actually the game object that this script is attached to. So you could type this .game object, or a shorter version of that would be just game object. Every mono behavior gets a free reference to a game object variable that is a reference just to the very game object that the script is on. So if we want to destroy the game object that the script is on, you just type destroy game object with a lowercase g. It's important to understand the difference between an instance of a game object, which would be the lowercase g, or in the entire class game object, which would be with an uppercase G. And we'll talk more about that difference a little bit later in the video because it's going to come up again. Okay, so if we save this and go back to Unity, I think we should be able to see our coin go away once we touch it. Oh, it didn't work. I don't know why. Let's figure it out. Oh, I know why. It's because we've neglected to actually put the collectible script on the caret. So don't forget that. So I'll just drag the collectible script onto this caret, and you should see it show up in the inspector here. Now let's give it another shot and see if it works. Yeah, so the caret is gone. I touched it, it's gone. That's cool. Okay, that's great, but we need to, you may have noticed when I touched the pink checkpoint, it has like all kinds of great feedback, like sound effects and a different animation and all that. So why don't we give the coin a little bit of a similar treatment where it'll at least play a coin pickup sound when I touch it. And remember, the way we made the checkpoint sound effect was with this bfxr.net program. I still have it on my computer, so I don't need to re-download it. But remember, this is just like a virtual synthesizer, and so I will use it to get a acceptable coin sound, at least for placeholder. So I'm just going to click. It actually has a pre-configured coin button, so just click it until you find one you like. I don't like that. I don't like that. There we go. That's kind of like the more traditional coin sound, in my opinion at least. I'm actually going to lower the frequency because it was really like high pitched. There we go. That sounds good. Alright. So I'm going to choose export wave here, and sure, I can just save it to my desktop. And then what I will need to do is go back to Unity. I'll stop my game. I will find my sound effects directory, and I need to drag that sound effect I just made, which was on my desktop. Let's drag that into the sound effects folder in my Unity project, and that's how you add assets. You just drag them into the assets directory in Unity. Alright, so you can see if you select it here, we have the sound effect. So that's working in Unity. We just need to tell it when to play. So select your caret game object, and we need to add an audio source component. Alright, there we go, and we need to tell the audio source component what is the audio clip that is going to be played by this audio source. So I will drag my coin sound effect into that slot there. Now if I play the game at this point, it should play the coin sound as soon as it starts. And that is because the play on awake button is checked. So I'm going to uncheck that. I don't want this to loop or anything like that, so I'm going to leave that unchecked. The rest of the settings I think will be okay for now. So now if I run the game, it's not going to play the sound effect right away. When do I want it to play? I want it to play when the player touches it. So let's revisit Visual Studio. So the way to get this to work, first of all, since we need to tell this component to play at a specific time in code, we need a reference to this audio source component in our script. So the pattern that we'll use this time around for that is to create a private variable of the type that matches the component in question. So it was an audio source. So I'm using capital A audio source because that's the type of the component that I'm looking for. And then I'm going to give that, remember I'm making a variable that I'm going to store a reference to that component in. And I'm going to name the variable audio source with a lowercase a. So I have a variable with a lowercase a. That's the name of my variable. This right here that's in green is the type of my variable. So it's named audio source just so it's clear just by seeing the name what it is. It is an instance of an audio source. And I know it's not a reference to the entire class audio source because it's just a lowercase a. Alright, so I have this variable for an audio source, but I can't just start using it. I have to initialize it. The way to do that in Unity would be to, let's go ahead and get our start function back. So I'll start typing start and then let IntelliSense fill it in for me. And remember, start is a special mono behavior Unity function that will get called automatically by the engine as soon as the scene loads. So as soon as the scene starts, I need to say this audio source variable that I made, it needs to, I need to set it equal to something. That's what initialization means. I need to initialize this variable with some starting value. And I want it to be equal to this specific audio source that's on my game object that my script is on. So you can see the collectible script and the audio source component are both just components on this caret game object. So if I want to find a reference to the very first audio source that's on the game object that this collectible script is on, I can call getComponent. And there's only one audio source on here, so I don't have to worry about grabbing the wrong one. So the syntax for getComponent is a little special where you get the angle brackets and you have to type in the type of the component you are looking for. And remember, the type is audio source with a capital A. So the capital A is helping us understand that this is a type of a thing, not an instance of the thing. Alright, so because it's a function, we just have to make sure we include the open close parentheses after the after specifying the type there in the angle brackets. So we're saying the audio source variable we declared at the top of our class is equal to the first component on this game object of the type audio source. That's what getComponent does. It searches this caret game object. Here's our caret game object. It's going to search it for the very first instance of an audio source that it finds, and then store that inside of our audio source variable. That's what the equal sign part does. It's storing the result of this function in this variable. So now that our audio source is actually set equal to something, it's been initialized, we are safe to go ahead and use it in our code. So I'm going to type in inside of this if statement. Remember, this is where we know the player has touched the coin. Something touched the coin. We check to see if the thing that touched the coin actually has the player tag. It does. So once we enter into this area of code, we know that the player touched our coin. So here's where we'll type in the name of our audio source variable, which is audio source with a lowercase a, equals, or not equals, I'm sorry. We want to do a thing. We want it to play. So that will play whatever audio clip is currently in it. Now, I'm going to save and go back to Unity and show you that this actually isn't going to work for me. We'll give it a shot. I'm going to move this checkpoint so that we don't hear it and get thrown off. So I'm going to play the game and then jump into the coin and see if we hear anything. I didn't hear anything at all, and we might be wondering why. The coin properly detected the player and removed itself, but we didn't hear the sound. And I can tell you why. It's because when we destroy the game object, the code is being executed line by line in a linear sequence here. So it checks this. It says, did you touch the player? Yes. Move to the next line. This is just nothing. Move to the next line. Play the audio. move to the next line. It does not wait for the audio to really finish. It just moves as fast as your computer is down to execute the very next line. So then it's immediately destroying the game object. So even though we are properly telling it to play, we are then turning around and telling it to destroy itself so fast that it is destroying it before us as human beings have even heard the first note of the sound effect. So we can test that by just commenting out this line, and in theory now I will hear the whole sound effect. Make sure you save and then flip back to Unity. I imagine I will hear the sound effect, but the coin will not go away. The carrot will be there forever. So yeah, I touched it, I heard the sound, but the coin is still there. Maybe I will move the coin so I don't have to have any kind of jumps to test my game. You want to make sure when you're doing game development, you create test situations that are very fast so that you can iterate quickly and test your work. You don't have to play through half your level just to test the one thing you're looking to test. Seems obvious, but I see a lot of students, like, they'll have to play through a whole level to test like one thing. It'll be wrong, and then they'll have to go change one thing again and try it again and see if they got it right. And so trust me, you'll save a lot of time if you create test situations that are very quick. So anyway, I move my spawn point and my coin right next to each other, and I can just walk into this. And it's playing, but it's not going away. So how do we resolve this? How do we make the coin go away, but also still play the sound? Well, one neat thing about destroy is that it has another version that takes a parameter for a delay. So after your game object here, hit comma, and you can see it says there's actually, so we were using this version of the destroy method where you just tell it what object you want to destroy. Now we're going to use the second version of the method that destroys the game object with an optional delay beforehand. So that sounds good. We can actually wait a little bit for our sound to play and then destroy the thing. So let's try that. Let's just type in, I'm just going to type in an arbitrary number here, like 4. So it'd be like 4 seconds. That's probably too long. Let's try like 2 seconds just for fun. Alright, so what's going to happen now is we'll play the sound effect. 2 seconds later, we'll destroy the coin. Let's save. Let's go try it out. Alright, well you can see just how long 2 seconds is there. But it did work. Now, let's think about this for a minute. This 2, if someone else were to look at this code, they would see this 2 and not really understand why there's a 2 there. What is the intent of this? I am not totally sure. So what we need to do is, this is what's called a magic number, and it's something you should try to avoid in programming. So magic numbers are just numbers that have no context. I don't know what this is for. So a better way to deal with it, we could make a temporary variable with a name. So we could say int, well, this should be a float, because you could have, maybe it actually needs to be like a half a second or something that's not actually a whole number. So it should be a float and not an int. And so we'll say float delay equals 2, right? And now, rather than just having 0 context on that 2, I understand, oh, okay, this is meant to be a delay before we destroy the game object. So that's a little bit better. But remember, we don't actually know how long it takes to play this. I'm just guessing. So rather than just kind of arbitrarily guess, even though this isn't a magic number anymore, it's better. I understand what this number is for now. I think we can come up with a value that's not just a guess. So luckily, if we were to type in, if we look at our audio source variable we made, and you hit period, you can kind of tunnel inside and see what's all in here. And there's actually a reference to the clip that is loaded in the audio source. And if I look inside of that clip by hitting period again, you can see there's actually a variable inside of the clip of the type float, which is what we need to supply this destroy function, and it represents the length of the audio clip in seconds. That's perfect. So if I use that length value here, it will actually destroy the coin as soon as the audio clip is done playing, because this number that we're passing in is exactly the length of our sound effect. So that is even more clear at this point. Now I really understand that we want this delay to be the length of our sound effect. So now I understand, okay, we're destroying the game object as soon as the sound is done playing. And there's no guesswork involved. Now, this will accomplish what I just said. If I run it, it'll destroy the game object for the coin as soon as the sound's done, but it's still not quite right. You'll notice what I mean. So it worked, but as a player, I expect immediate feedback when I touch this coin. The sound is working, but I expect the coin to go away instantly, in addition to the sound playing all the way out. So my problem now is that I want the sound to keep playing, but I want the coin to visually be disappeared when as soon as I touch it, like instantly. That small difference makes a lot of it's a big impact on your player's experience, even though it's just a matter of probably less than a second. So we need to figure out a way to make the coin seem like it's went away, but not completely destroy this game object, because if we completely destroy the game object, we're taking out the audio source with it, and it can't finish the sound effect. So if we select the caret, remember that each game object in Unity is composed of a variety of components. We know that if we were to, for example, turn off this audio source, we would no longer hear it play the sound, right? Well, one of these components is actually controlling drawing the caret, and that is the Sprite Renderer. So in 2D, sprites are drawn by the Sprite Renderer component. That's sort of what's making it a sprite. So you can see if I disable that by unchecking it, the image is going away. So what I can do, since I know by using getComponent, I can get a reference to this variable, or this component rather, and do stuff with it, why don't I get a reference to the Sprite Renderer and change it when I want it to go away? I can just turn it off, and it'll look like it's gone, even though secretly the game object itself is still there. So let's try that strategy. We'll follow the same pattern here, where we make a private variable of the type that matches the component we're looking for, and then we'll name the variable the same thing except with a lowercase starting letter there. So private Sprite Renderer with a capital to designate the type, Sprite Renderer with a lowercase to designate a name. Alright, so we have a variable of the type Sprite Renderer. Remember, we have to initialize it. We'll do that in start also. So we'll say Sprite Renderer. Our instance variable here of a Sprite Renderer is going to be set equal to a component of the type Sprite Renderer that is on our game object, right? It's on the very game object that this script is on. So we'll remember our getComponent. It'll search the whole game object, all of its components here, for the first thing of the type Sprite Renderer, because that's what I passed inside of the angle brackets. And then it will store that inside of this variable Sprite Renderer. So now I have a nifty reference to my Sprite Renderer. And so what I can do, as soon as the player touches the coin, I can turn that thing off. So the way you disable a component is by typing the variable that we made that represents that component, and we'll say .enabled equals false. And what that will do is essentially just uncheck this box. That's what setting a component to disabled is, just like unchecking that box. So let's save it and test it out, and I would expect now it will appear that the coin is gone as soon as I touch its collider, but it will secretly still be there playing its sound until the sound is finished, and then it will go away. So observe the caret in the hierarchy here. You can see when it actually goes away versus when the image goes away. So you can see the timing there. But check this out. There's a new bug. It almost works well, but if you really try, because the caret is hanging out for longer than it looks like it is, there's still going to remain an invisible collider. This box collider is still there. And so if I walk back into the region where the collider is, I can actually collect this coin a couple times before it disappears and destroys itself. So we can test that. I don't know if my move speed is fast enough. Let's see. Man, you might just have to take my word for this, or I could maybe make the player a lot more responsive temporarily here. So maybe if I make the acceleration force doubled and the max speed higher, I will have the reaction time I need to get this coin a couple times. Let's see. I don't know. Well, just believe me on this one. You'll one day have that bug. I can show you exactly what I mean here. If I leave the game window somewhere that I can see the scene window at the same time, just watch the green hitbox is still going to be there. I just couldn't walk back into it in time. We don't want to leave that bug open, so it's a pretty easy fix anyhow. All we need to do is just follow the same pattern we've already done to turn off the sprite renderer like that. Well, we can also turn off the hitbox like that. So if we turn off the hitbox, there'll be no way the player can possibly activate the coin twice. So we will just do the same thing. We'll make a private variable this time of the type box collider 2D, and we'll name it box collider 2D with a lowercase b, and we will initialize it in start. So box collider 2D equals get component box collider 2D open close parenthesis, and then right here where we're disabling the sprite renderer, we will just also disable the box collider, just in case there's any pro gamers out there who have fast enough reflexes to collect our coin multiple times before the sound effect is done. Or if I change my mind and choose a longer sound effect that makes it easier to collect multiple times, this will accommodate that. So now if I go, let's move the game window back over again and observe the green box. The green box will go away as soon as the player touches it the first time. That was hard to tell. That's almost so hard to tell, I'm not convinced it's working. But I bet it is. We would want to set up a test case here. So why don't we do something like this? Let's go over to this and where we're destroying the sound effect, and let's like add some long time to it so it's really easy to walk in and out of that region. So I'll just make it take like however long this is plus 10 more seconds, which is a long time, and we'll see if we can collect it multiple times. And you know, if I were to choose a different tool other than this rectangle tool, like maybe if I choose this tool, it'll help me see the green box easier without creating an additional outline around the sprite. Like see, if I turn this off, there's still an outline, and that was making it hard to see too. So let's choose like the move tool or the whatever this is, hand tool, and watch this again and see what it looks like. Yeah, did you see how now in 10 seconds you'll see the whole thing go away here? But I could see that the green hitbox was actually going away instantly. Cool, so there you go. You can see we did actually fix the bug. I'm going to make sure I remember to get rid of the arbitrary delay that was just for debugging and save it all up. Now, the next thing I'm going to want to do, it's presumably we're going to want to have many of these carrots in our game, right? I don't actually need the animation window open anymore. I'm going to hide it a little so we have more real estate to look at. So in games, you normally have lots of coins. Actually, you see this speaker? It's like taking up a ton of room. I'm going to get rid of that too. So if you look over here so I'm in my scene window, there's a thing called Gizmos. I can uncheck these gizmos, like I'll uncheck the audio source gizmo. I thought that would make it not draw. Evidently, that's not true. So we'll just do something like this. How about that? There we go. I'll just scale it down quite a bit. And that way I can see my coin easier. Alright, so like I said, games with coins normally have more than one. So anytime we have something that's going to be duplicated, we should probably make it a prefab. Like in case, that way if I decide it should have a new sound effect, I don't have to go into every single coin and manually change the sound clip. I can actually just change it once and all of them will update at the same time. Or same thing if I needed to change the animation or anything about the coin. Change its hitbox size, who knows. So we'll go to our prefabs folder here, and I'm going to drag the caret game object into the prefabs. And now if I want more coins, I can just drag them on in. So we can do something like that, and now I can collect a bunch of coins and it'll be fun, right? Cool. Alright, so we've got a prefab, that's good. The next thing we should probably do is actually keep track of how many coins you've collected now that there's more than one. So let's think about that a little bit. Probably we should have a variable that keeps track of how many coins you've collected. So we'll make a private variable, we'll call it coin count, or I guess since this is not necessarily a coin, maybe that's not the best name, but whatever, I'm going to call it coin count. That's fine with me. You could manually initialize an int to 0. Oh yeah, to tell it it's an int, right? So what type should this variable be? Well, you can't have half a coin, right? So it should be an integer, which just means there's no decimal points. And we want to start at 0. 0, so we're initializing at 0. That's kind of happens by default, so if you wanted, you could just put a semicolon there. Since this is a primitive type like int, Unity can or I guess C# automatically initializes it at 0, but things like Sprite Renderer and Audio Source and Box Collider, they cannot automatically initialize. There's no default value for these things. That's why we had to go in and manually initialize them here. And we wouldn't want a default value anyway. We need to make sure that they have the specific value that we need, which is the audio source that's actually on this game object, right? Not some random default one. But in this case, the default value is fine, 0. We want to start at 0 coins. So when you touch the coin, it should go up. So what we can do inside of, well, let's just do this. So when you touch the coin, we will say coin count plus plus. That's the little shorthand for incrementing by 1. So it'll change the value equal to 1 plus whatever it used to be. And that's perfect for collecting a coin. And we will then log the coin count. So we'll say debug.log coin count plus coin count. So we'll print out this plus the value of whatever coin count is. Okay, so let's see what this does. I kind of actually, I'm going to change my scene a little bit more because this is kind of a confusing test case and I want to make it simpler. I need to get rid of this hand tool, I guess. There we go. Alright, so let's just move this even further out of the way here. And, well, we can actually go back to the rectangle tool. That's generally better for sprites. I'll move my player to start right here. And we can take this coin and put it here. So now there's just an easy test case where you don't have to jump and collect like a million at once. We can just individually hit them and see what happens. Alright, so, oops, I'm off camera. One day we'll have to fix our camera, but you can see this rectangle, this white rectangle represents what the camera can see. I guess a super nasty quick fix for it is we can actually make the camera a child of the player. And so game objects that are children of something will follow them around. So the camera will follow my player around, and I'm going to choose the starting X will be 0 so that it starts centered around my player. So don't change the Y of your camera, but you can change the X and the Y. I'm sorry. Do change the X and the Y. Do not change the Z. That will screw things up. Z is like how far back from the scene the camera is, like in 3D space. We don't want to mess with that. We do want to follow the X and Y of the player. So your camera can have a 0, 0 and be a child of the player. And then you can see it'll follow my guy around. Anyway, so look, that's a bad camera setup, by the way. We can do a better one with something called Cinemachine really easily, but that's another tutorial. So anyway, we touched the coin, it says coin count 1. Alright, that makes sense. That was the first coin. Let's move over here. Well, wait a minute, I touched the coin and it still says coin count 1. Oh no, what's happening? It's always saying coin count 1. Well, that's because of the difference. Essentially, the variable coin count here is an instance variable. What does that mean? It means that every instance of our collectible has its own coin count. That might sound really confusing, and I get it. But a good way to think about it is each instance of these collectibles, they all have their own position, right? They don't just share a single position. Otherwise, that would mean every coin was just stacked up in the exact same spot, and that's not good. We want them to have, each instance of a coin has its own position variable so that they can be in different positions, right? Each one has its own box collider. We don't want them to share one hitbox. So like if I touch the first one, every coin in the whole world gets collected. That would be bad, right? But yet, for this coin count, we do want the coins to all share one variable. So luckily in C# there's functionality for that, and it's called static. So I made this kind of crappy little image you can look at. So here's our collectible class, right? And it's basically, you can think of a class as kind of like a factory, or in this case I have a rubber stamp. The class itself starts with an uppercase, and you never are really dealing with just the class itself. The class itself is only there for making instances of it. So it just stamps out little instances of the class. So we're never using the collectible with an uppercase C. We're actually just using it to spawn these little collectible with lowercase c's. So whenever we talk about the difference between a class that starts with an uppercase, that's talking about like the concept of that thing, the stamp, the factory, the thing that makes instances of that type. This is the type itself. The instances are instances of that type. It's maybe you get it easily, maybe it's really confusing, but it's important to understand that difference. It's very integral to object-oriented programming. So as we noticed, every instance has all these different variables that belong to it, right? Each instance has its own position, its own collider, and the way we have it programmed right now, it has its own coin count. But what we need to move towards, because having every coin having its own coin count is silly, because it'll only ever go to 1, because then we're destroying the coin and then you can never collect it again, right? So what we need to move towards is this situation where the class itself has what's called a static variable called coin count. So we've moved coin count is no longer belonging to instances of the class. It's actually belonging to the class itself. And so if we do that, and we make this one go up every time the player collects any of the instances, we will know how many the player has ever collected, because there's just one shared variable here, right? So that's what we're going to do. That's what static does. Static changes a variable from belonging to an instance to instead belonging to the class itself. So it's super useful for things like this. So rather than just saying private int coin count, we're going to say private static int coin count. And that's all it takes. So now we are still changing the value of that variable whenever the player enters the collider, but it's just there's only one of those variables now. It's owned by the entire class. There's not like a million different little ones. So whenever we change coin count, it's actually changing the coin count that belongs to the whole class. So now we should get the counting and incrementing that we expect. So we can save and run the game. And let's collect the first one. We know that'll say 1. Right, but here's the big moment of truth. What happens when I touch the next one? And check it out, coin count 2. Now let's go for the next one, coin count 3, and coin count 4. So this is working. Alright, so I'm going to leave this video here. We've kind of went over a lot. We've figured out how to do a sprite sheet animation. We figured out how to get our coin to play a sound and get collected, and figured out how to track that by understanding the difference between a static variable and an instance variable. The next thing I think we should probably figure out is how do we print this number somewhere on the screen instead of just in this debug output here in the console. But I think that's a whole nother can of worms, so we will save that for a future video.